All right, Algebra 1B students, welcome to part 1 of lesson 10.3. In today's lesson, we will be adding and subtracting square roots that have numbers in front of them, and you'll see what I mean by that in just a minute. The first thing that we need to deal with is some new vocabulary that's very much like thinking of like terms or unlike terms. Just as a reminder, 3x and 4x are like terms. You can add them together if you want to. Okay, now 3x and 4x to the third power are not like terms. You cannot add those together even if you want to. In a similar fashion, 3y and 4x are not like terms because their variables are different. You cannot add those together. When we deal with square roots, we have exactly the same idea. We have what are called like radicals. Like radicals means they have the same number under the square root. In this case, 3 square roots of 5 and 7 square roots of 5. You can add those and subtract those together just like you can if both of those have an x on them. Okay, 3x and 4x. If, however, you have two radical expressions, one that says 4 square roots of 3, the other being negative 2 square roots of 2, notice that the 3 and the 2 under the square root are not the same number. Therefore, those are unlike radicals. They are not alike, and therefore, you cannot add them or subtract them. Okay? Now, if we have like radicals, as I mentioned before, we can add and subtract them just like we do with x or y or some other variable. Okay? We just imagine that that square root piece is like a variable and we leave it alone and leave it in our answer. So 7 square roots of 2 minus 8 square roots of 2, which is what I have here in letter A. If I want to subtract those two, I imagine that this square root of 2 here is like an x, and that one's like an x. 7 of them take away 8 of them. Well, 7 minus 8 is negative 1 of them, and I still have square root of 2. So it's negative 1 square root of 2, or just negative square root of 2. In letter B, if I have 5 square roots of 5, plus 2 square roots of 5, because both of those are square root of 5, I can add them up. 5 plus 2 gives me 7 square roots of 5. So I treat the square root of 5 just like it was an x, just like it was some object that I was dealing with. And I have 5 of them here, I have 2 of them here, I add them up and I have 7 total. Okay. So when they are like radicals, I am allowed to add and subtract. Now, if they are not like radicals, for example, 5 square roots of 3 minus the square root of 12. Those square root numbers are not the same, but I believe I can simplify this square root of 12 right there. I believe I can simplify it by looking for a perfect square number that goes into it and see what I end up with. So I'm going to do that. I'm going to first deal with the square root of 12. I believe the square root of 12 is the same as the square root of 4 times 3. I choose 4 and 3 because 4 is a perfect square number. So I can then split the 12 into the square root of 4 and the square root of 3. Now I know what the square root of 4 is. I know what that is. It's 2. So that is 2 square roots of 3. Now, I would have to put a plus or minus, except they have this minus sign here for me, so I know it's going to be a minus 2 square roots of 3. So because I was able to change that square root of 12 to be 2 square roots of 3, now my expression says 5 square root of 3 minus 2 square root of 3, and we all know that that means 5 take away 2 gives me 3 square root of 3. So we can look to simplify these radicals and then add or subtract them once those square root numbers are the same. Let's look at number 2, letter A, together. They're asking us again to simplify this expression. That means put it together if we can. So we're going to look here and see if we can put these together. Now, I have 4 square roots of 7. I don't think I can simplify the square root of 7 at all. Plus 2 square roots of 28. Those are not the same square root number, but I can simplify the square root of 28. So the square root of 28 is, I believe, 4 goes into that. 4 times 7. So I'm going to split the square root of 28 into the square root of 4 and the square root of 7 multiplied together. And I still have the 2 multiplied out front. 2 times. 2 times the square root of 4 times the square root of 7. I split that square root of 28. Okay? Now I know the square root of 4 is 2 again. And again, because they give me a plus sign here, I don't have to worry about that plus or minus. So I will say this is 2 times the square root of 7. Well, 2 times 2 I know is 4. So that is 4 times the square root of 7. And now I want you to notice that I have, from the beginning of my expression, a 4 square root of 7 plus another 4 square root of 7. If I add those two together, 4 plus 4 gives me 8 square roots of 7. 8 square roots of 7. Now, I would like you to look at letter B. Take a look at this problem here. 5 square roots of 32 minus 4 square roots of 18. Simplify both of those radicals because you can. And then simplify and put those two together. Once you have the same square root number, you're allowed to do that. Take a look at that, pause the video, come on back, and I'll show you what we should get. All right, now the square root of 32 can be split into 16 and 2, which means that becomes 4 square roots of 2. 16 square rooted is there, that's 2 times by 5. That's 20 square roots of 2. 18 can be split into 9 and 2, which means that's 3 square roots of 2. 3 times square root of 2. Because I split it into 9 and 2 right there, 9 and 2. 4 times 2, that's 12 square roots of 2. So now I have 20 square root of 2 minus 12 square root of 2. And 20 minus 12, since they have the same square root number, I can put them together. 8 square root of 2. That's what we should get there. 8 square root of 2. If you have questions about simplifying and then adding or subtracting square roots, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.